Hello students and welcome to lecture 6 part B. In this lecture we are going to look at some types of supports and their reactions. There are three basic types of supports that we have here. One is the fixed support where your force member is actually fixed to the supporting surface. Then we have a second type which is pin or hinge support. It is represented as this triangular support. And finally you will have a roller support which is a combination of the pin and also shows these two rollers attached to it. Okay, so we will go through one by one and see what kind of reaction they will possess. Starting with the first one, which is a fixed support. As we can see that it is fixed to a surface, so if you try to pull it horizontally or push it, so there will be no motion, no horizontal motion, and that would be because you will have a reaction uh, force produced at the fixed support region that will try to stop your motion. Also, the reaction force will be perpendicular to the support surface in this case. The direction of the force will depend whether you are trying to pull the body or push the body. In this case, if you are trying to push, it will try to oppose your force and you will not be able to move the body. Now secondly, let's say you want to move the body up and down, or you are trying to apply a vertical force. You will not be able to move the body because it is fixed, and your force will be again resisted by a reaction force that will be again depending on which direction you are applying the force. So it will be the reaction will be opposite to your applied force. So you will have a second reaction that will stop the motion in the vertical direction as well. Finally, if let's say you are trying to apply a force here that is trying to rotate or create a moment in the body, of course the fixed support is not going to allow you to do that, and there will be again a reaction of moment created trying to stop your moment. Okay, that moment or the reaction moment will again be equal to your applied moment. Okay, so there will be a third reaction, and that will be the moment created trying to stop your motion. Again, the direction of moment will depend on your applied moment. So as a fixed support, there will be no displacement. It will be stopped by your Fx and Fy, or the forces that are parallel to the reaction force that is parallel to the surface Fy, and the reaction force that is perpendicular to the surface Fx. So there will be no displacement. Additionally, there will be no rotation in the fixed support because it will be resisted by your induced reaction moment. Okay, so a basic example of a fixed support can be a beam something like this, that will actually, if you try to move it horizontally or vertically, it will not move because it is fixed to this surface. Okay, and there will be a reaction produced to stop your motion. Similarly, if you, let's say, try to apply a force that is trying to create a moment or rotate the body, you will not be able to rotate because there will be a reaction moment by this support which will stop your moment. Okay, so in this case you actually get three reactions: the Fx, Fy, and the moment. Now let's move on to the second support, which is pin or hinge support. In this case, it is represented as this triangle. Okay, and it is free to rotate. Now, unlike fixed support, which is not even able to rotate, in this case you are giving it a freedom to rotate. So because of that, out of these three reactions, because it is free to rotate, this moment, there will be no reaction to the moment. There will be nothing to stop the rotation, so you will have no reaction moment produced, so that can go away. Now you will be left with two reaction, that is Fx and Fy, or in other words, the reaction force parallel to the surface and reaction force perpendicular to the support surface. Okay, now this is in the problems can look something like this, and the only freedom you have is the rotation. Okay, and of course you will have two reaction forces created in case of the pin or hinge support. A very basic example would be your door hinge, which is actually able to rotate, okay, but it cannot move up. Okay, it cannot move sideways and the reason is there will be reaction forces created that will try to stop your motion, upward motion and the horizontal motion, but you are free to rotate. Okay, now let's move on to our third support, which is a roller support. Again, it is shown as a triangle, and then you have these two rollers attached to it. This triangle means that the body is free to rotate, similar to the pin joint. So if it is free to rotate, that means that you will not have any reaction moment. So free to rotate, there is nothing stopping the rotation, so there will be no reaction moment. Now additionally, if you look, there are two rollers attached, which actually means that uh, the body will be able to translate, so it allows movement parallel to the supporting surface. Okay, so it can move from this location to, let's say, this location. Okay, so it can move as shown here. So now it has a freedom to translate along the surface. Okay, so it can move along the surface. So that would mean that now this reaction force will not be there. It is not trying to stop the motion parallel to the supporting surface, so there will be no reaction force parallel to the supporting surface. Okay, because it is free to translate parallel to the supporting surface, so you will only be left with the Fy, which is the force perpendicular to the supporting surface. So in case of roller joints or roller supports, you will have only one reaction force that will be perpendicular to the supporting surface. Now in problems, these roller supports can look something like this. This has multiple cylinders that actually allows this motion, but there will be a reaction force that will be trying to stop you. So that will be your Fy, or reaction force, in case of roller supports. They can look like this as well, like for example one cylinder, or it might look something like this. These are also called the rocker support. They also act in the same way as the roller supports. Okay, and keep in mind that in this case, as these are horizontal, so your reaction force will be something like this, which will be again perpendicular to the supporting surface, but it is possible that they are not horizontal and they are having the supporting surface inclined. So again, your reaction support force will be perpendicular to your uh, supporting surface in all three cases, as you can see. Okay, so then we also will have this problem. I hope the supporting support and their reactions are clear now. So in pin support, you have or in fixed support, you have all the three reactions. Okay, so there is no displacement, no rotation. You will have the a force parallel to the surface, you will have a force perpendicular to the surface, and you will have a moment that will try to stop any rotation in the fixed support. In case of pin support, uh, the moment will not be there because it is free to rotate, so there will be no reaction moment, so you will be only left with the two forces that will try to stop your displacement. And finally, in the roller support, now one of those displacement is freedom, so you can actually move along the surface, so there will be no reaction force parallel to the surface as well. Okay, so you will be only left with one reaction force in case of roller supports. All right, I hope it is clear, and then in the next lecture we will actually solve this problem, in which we will determine the horizontal and vertical component of the reaction forces at pin A, and then we have a rocker or a roller support at pin at point B. Okay, and we will try to sort out what are those reaction forces or moment, if there is any, at these points. Okay, I hope it is clear. We'll see you in the next lecture, in which we will solve this problem, and take care. Bye.